So let's start our meeting today by a reminder what we covered before. To give you a hint, we started this course. We have a land area of land. We need to cover it, or we need to build warehouse. The first step to start your project, we need to do something called layout. I will select a main system. This main system can be truss, looks like this, or can be frame, looks like this. That makes sense? Previously, we covered everything related to your truss. Today, we will talk about frame. Frame, you will see nothing new except a few points. First of all, this main system will be repeated every equal spacing, which is called S. This S is very important to calculate your loading. So the first step, we have a frame, that's fine. Your plan will be looks like this. And we have S, which is the spacing between frames. That's fine, no problem. Then you will able to put your purlin. Make sure we have two adjacent purlin here. Then we have purlins will be repeated maybe every 5 feet, 6 feet, whatever. And this purlin will be located here. That makes sense? We learned it before, probably 2 weeks ago, how to design purlin. We learned how to design purlin. We learned also how to design each member in your truss. Today, we will start to talk about the frame itself. We have a frame and we need to design it. As you remember from the truss analysis, the first step is loading. I will start to talk about the dead load. Please pay attention. You will find something, it's not new, but a little. We have a little new. Your structure, as you see here, we have purlins, we have bracing, probably horizontal bracing, and we have corrugated sheet, and we have many things should be considered as dead load. So for dead load, we have two categories. The first one is called weight of the steel structure itself, and the second one, weight of the covering material. I will assume the weight of the steel structure, W steel, which is the weight of purlin, the weight of wind bracing, the weight of the frame element itself. I will assume it's something between 100 to 200 pounds per square feet, and make sure this assumed value is considered horizontal projection. This assumed value is considered horizontal projection. I will show you what is the difference between horizontal projection and inclined projection. We have weight of covering. This covering can be corrugated sheet only, or can be concrete slab. If you have corrugated sheet, I'm gonna assume it's something between 25 to 50. If you have steel concrete slab, I will assume it. I will calculate it, not assume it. Gamma concrete, which is 150 times thickness of this concrete slab. Make sure the weight of the covering material is called W covering, WC. The weight of the steel structure is called W steel. I will assume this value, for example, W steel equal 150 pound per square feet. and I'm gonna assume I have corrugated sheet. I'm gonna assume W covering equal 30 pound per square feet. Does that make sense? Then, since each frame is supporting from center line to center line, I will multiply the assumed value for W structure by S. The assumed value for W covering by S divided by cosine theta. Here is your theta. This inclination angle theta, I will multiply. I assumed here, for example, assume we have a spacing equal, for example, 25 feet. So the value of S will be 25 feet. 25 feet. I assumed the W structure equal 150. So this value will be 150. W covering, I assumed it to be 30 pounds per square feet. And I will calculate the angle of inclination for this sloped part, assume, for example, equal 10 degree, for example. So I will divide it by cosine 10 degree. Then you can figure out the W of dead load, 150 times 25 plus 30 times 25 divided by cosine 10. I got here 4,511.6 pound per foot. I can divide it to by 1,000 to be 4.5 kb per foot. This load is uniform distributed load, but horizontal projection. Horizontal projection. I will show you on Monday how can we define horizontal projection on RISA. But right now, keep in your mind, this assumed value is considered horizontal projection. This assumed value is considered inclined projection. Unfortunately, I cannot add this one to this one directly. I need to convert one to the other one. So I converted this one to this one. How? By dividing by cosine theta. So dividing by cosine theta just to convert from inclined projection to horizontal projection. I added them to this fact, this term. The final value will be horizontal projection. Let me explain you 2 points here. The first point, anybody remember in the truss, we said the value of the dead load equal W structure multiplied by S multiplied by A. Do you remember that? A was the spacing between purlins. This is A. In frame, we did not. B dead load equal W plus something. W structure time S only without A. The results here, I will convert the dead load to be one concentrated load at each node of your truss. But for frame, no, your dead load will be uniform distributed load over the sloped part of your frame. This is the main difference between truss and the frame. This is the first difference between truss and the frame. I will not convert your load to concentrated load on the frame. This is acceptable in truss, but not accepted for frame. This is the reason why I used only S. This is the first point. The second point, what is the difference between horizontal projection and inclined projection? This difference only exists if you have inclined or sloped surface. If you have a sloped surface, we will have this difference between horizontal projection and inclined projection. What you mean? I mean, if you have uniform distributed load over this inclined surface, and this distributed load is horizontal projection, and the value of this distributed load is W, if you would like to convert this distributed load to equivalent, you have to multiply W by L, the horizontal length of this inclined member. But if you have uniform distributed load, and this uniform distributed load is called inclined projection, and the value is W, the equivalent load for this distributed load will be W L bar. So L dash or L bar is the inclined length of the sloped surface. This is the main difference between horizontal projection and inclined projection. Unfortunately, if you have W equal 5 inclined projection, and we have W equal 2 horizontal projection, I cannot say W total equal 5 plus 2. I can equal 7. I cannot do this. We cannot add them together until you convert one to the other one. And this is the reason why we divided here by cosine theta to convert this term to be horizontal projection. Then we can add it to this term. So the final answer will be horizontal projection. Anybody in this meeting has any question regarding the first difference and this difference? Keep in your mind, for truss, we are using another term, another dimension, which is A, to convert your dead load to one concentrated load at each node. For frame, no need for this. No need for this. Your frame can support uniform distributed load over the members. So I used only S. The second point, what is the difference between horizontal projection and inclined projection? Inclined projection only. This difference will not happen only if you until you have inclined surface. The horizontal projection means the equivalent will be multiplied by the horizontal distance. Inclined projection means the equivalent will be multiplied by the inclined distance. Anybody in this room, in this meeting, has any question regarding this point? Okay. For live load, if you have live load, I will not say something new. Everything is the same. If you have flat surface or sloping, and this sloping has an angle equal 10 degree or less, this angle of inclination for this sloped surface equal smaller than or equal 10 degree, then I can say if you have access to this roof, the live load equal 30. If you don't have access, the live load equal 15. And this live load will be bound per square feet over area. Bound per area. If you have a sloping roof and the angle is greater than 10, your live load will equal this equation. 15 minus 0.5 times theta minus 10. And this value must be greater than or equal 8.5. So based on this angle, which is greater than 10 degree, I will put it here, and I will set up this equation to find out the live load. Make sure the value is greater than or equal 8.5. If it's smaller than 8.5, I'm gonna use 8.5. Once you get the live load, I need to multiply this live load by S only. Then your live load will be distributed load over this frame, and this live load is horizontal projection. So keep in your mind, your dead load is horizontal projection, your live load is horizontal projection. Assume your angle theta equal 10 degree and we have axis, then the live load equal 30. The spacing between the main system in our example is 25 feet. So I will put here 25. Then I can say 750 pound per foot, or I can say 0.75 kb per foot. That makes sense? This is the value of live load. And your live load is horizontal projection. Distributed load, horizontal projection. If you remember, for truss, for live load, W live load, we need to multiply live load by S by A. Why? We use the A for truss because we need to convert the live load to one concentrated load at each node, at each joint of the truss. No need for this. If you have frame, I'm gonna use only live load time S. And then I converted the live load to distributed load over the frame. Looks good. For wind, everything the same. We have fluctuating pressure equation to calculate the QZ. Then I'm gonna use QZ in this expression to figure out the pressure. Once you get the pressure over the windward, leeward, windward slope or roof, leeward roof, this pressure, this value of pressure here, this value of pressure here, this value of pressure here, this value of pressure here will be multiplied by S to convert your pressure to distributed load over the frame. And keep in your mind, if this is the windward, we will have uniform distributed load compression. This is the leeward, we will have suction. And this is the windward roof, we will have suction, and this one will be suction. Keep in your mind, the wind load is perpendicular to the surface. Perpendicular. If you have inclined surface, the direction of the wind load will be perpendicular. If you went back to truss, you will find the W for wind load equal pressure time S time A. Why? Because we will convert the pressure of the live load or the pressure of the wind load to concentrated load at each node, at each joint of the truss. This is not the case for frame. We need only W wind load equals the pressure time S. No need for anything else. Any question? If you have any question at any time, let me know. For snow load, everything the same, no change. For snow load, we have two cases. If you have flat roof means something flat like this, without a slope. Then the weight or the load of the snow equal this expression. PG, this value based on the location of your building, based on this map, I can figure out the value of PG. For Texas, it's around 5. If you go northeast, you will be 25, maybe 20, 25. If you go north, it will be something like 60, 40, because we expect much snow. But if your roof is sloped like our frame, then your sloped value will be the flat value times CS, and the CS can be determined from this chart based on the angle theta. I will, if your angle, assume your angle equal 10, I will go up here from 10. until you hit the solid line, then I can figure out the value equal 1. If you go for bigger angle theta equal, for example, 50. If you go 50, then your value will be 0.6. That makes sense? Once you determine the value of the snow load, then you need to multiply this snow load value by S to convert it to kip per foot horizontal projection. That makes sense? If you go back to the truss, the W for snow load equal PS time S time A. Why? Multiply by S and A, because we need to convert the snow load to one concentrated load at each node. This is not the case for frame. You need only to multiply PS by S, the spacing between the frames, and then you will convert your snow load to distributed load over the frame, and this distributed load will be horizontal projection. Once you have your frame and we have value for dead load, another value for live load, another value for snow load, all of them horizontal projection, and force value for wind load like this, and like this, and like this. This is for wind, and like this. We have all of them. I will open RISA 2D to draw my frame, define these loads, and analyze the frame. The final conclusion that we will have axial force diagram, shear force diagram, bending moment diagram. These are the expected results from RISA for your frame. These are the expected results from RISA for your frame. We will go through them on Monday, how to use RISA to analyze your frame. They are included here. But just a reminder, if you look to this member, this is axial force diagram. That means we will have P ultimate equal 29.3 kip. This is the value here. For the same member, if you look to the shear force diagram, we have V ultimate equal 18 kip. For the same member, if you look here, the biggest value will be moment M ultimate equal 88.3 kip foot. So I can design the member against shear. We learned that V ultimate must be smaller than or equal, I think, phi Vn, and Vn equal 0.6 if yield area width. We covered this before. Last meeting on Monday, we learned if you have a member under the effect of P ultimate and the M ultimate at the same time, looks like your frame member, the column here, we have P ultimate and we have M ultimate. So the design of this member will be using this expression. If you have axial load, P ultimate, and if you have axial load, axial compression P ultimate, and bending moment M ultimate at the same time, we will design or check our member using one of these two expressions based on this case or this case. That makes sense? That makes sense? This is the reason why we covered many cases for your design, because your frame, we will have 3 diagrams: axial force, shear force, and the bending moment. So we have sometimes shear, sometimes we have moment and the axial force, both of them at the same time. So we need to design our member by considering this case. So this is the plan for the next meeting. We will have a dead load, a live load. We should have a snow load also, and the snow load and wind load. All of them are given. I will use Risa to analyze this frame, and I will go through solved examples and the design from A to Z. Okay, but right now we have we took a quick review on loading, and looks like everything is the same, except when you convert your loading to direct load on the frame, we are using S only. For truss, we are using S time A, because for truss, we need to convert the applied load to one concentrated load at each joint. For frame, no need for this, just only distributed load. So we eliminate the second term, which is A. Guys, do you have any question?